Good morning. So continuing on with our walkthrough of the first activity, this section will be more detail and reminders about the different types of fault lines and boundaries and the natural disasters that are caused by the movement of these tectonic plates at these different boundary lines. So we talked about earthquakes, volcanoes, and tsunamis, at least I'd mentioned it yesterday, but also landslides. Now, tectonic activity is not the only cause of a landslide. There are other things that cause it, but you can get landslides from earthquakes as well as from the eruption of volcanoes. So this is a more detailed look at the subduction zones. The different boundaries. We're starting off with subduction zones, and that is where one plate, when they collide, gets pushed under. So there is a certain plate that goes up and there's a certain plate that goes down. As you can see on the screen here, continental plates, so they're bigger, they're heavier, they've got landmass on top of them. They're the ones that have the continental landmasses on them, hence continental plates, versus the oceanic plates. So the water is heavy. The fact that there's no landmass on it does make it weaker in a way. So the oceanic plate will always get pushed under the continental plate and create that subduction zone. So there's still scraping here where we meet, and there's still enough pressure from the ocean plate that kind of bends and folds to create mountains. You see that along our west coast. That's how the Rocky Mountains were formed. Then we have convergent boundaries, continental collision. So this is where it's very rare. There's only one place in the world where this happens, that there are two continental plates that are moving towards each other and constantly crashing because they're both continental plates. They both have enough mass that neither one will give, so they go up. And this creates the highest mountain ranges known to man, which is the Himalayas, which, of course, Mount Everest is the tallest mountain in the world and is tall because of the fact that it is a fold mountain from two continental plates. So we have volcanic hotspots, which happen at a certain type of collision point. There's a nice little video there that explains it, but they are more, they're smaller, finer lines between, kind of like mini cracks between small plates. Now, it's easy for us to think about the crust that covers the Earth as just large puzzle pieces floating, but there are smaller puzzle pieces that fit in as you look around. If you were to look at the globe and just see the plates. This is where there are fissures and things through it. So, and where it's constantly moving apart. You can see that, as they say here, you can see Hawaiian Islands. So Hawaii did not exist. It is a new growing landmass. And it is kind of, if you look at the overarching large plates in the middle of the Pacific Ocean plate. But that's where we get to and see those smaller plates that may happen within and around that. Because they're constantly moving away from each other, it's causing spots for that lava and magma. One is above, one is below ground. Anyways, for the mantle to come out and constantly be creating new ground. Now, in some parts of Hawaii, it is a very safe thing. It's happening on the edges or on non-populated islands because they're constantly changing and growing. New islands and little land masses are constantly popping up. And oftentimes you'll see those videos of globs falling into the sea and the big hissing and the steam. That is the safest way that you can see these land masses forming and growing from these hotspots. But unfortunately, I think it was about 2 years ago, they did have larger, kind of an eruption, not quite, but you could see it moving much quicker, and it started to destroy homes and did cause fires. And when those happen in more populated areas, you do see the interaction between nature and human environment, and you get that clash that becomes known as natural disasters. So another type of divergent boundary is rift valleys. So it's where giant chasms, big cracks form as they pull away. You see this in the mid-Atlantic Ocean ridge. It is the deepest place on Earth, and as those two plates pull apart, it's just a giant, giant crack that continues to go down. Yes, magma does boil up and go over and come out, and then we do have underwater ocean mountain ranges, which is really cool from some of it, whereas others, it is just a giant crack. And then our last one is transform boundaries. The most famous one that you may have heard of is the San Andreas Fault in California. So transform, neither one is pushing on each other. They're not pulling away. They're sliding past each other. And it's when they catch and then they release that we have earthquakes. The last largest one in California was back in the 30s. And, the scientists say that we could be set for another big one. There's been lots of movies made about it, the San Andreas movie specifically, about what would happen if that massive earthquake comes. They have taken precautions. Most new housing developments and large-scale skyscrapers are made with special precautions taken against earthquakes, with their building materials and the way that the building is structured. But that does not necessarily mean that it'll be more safe, but there is no way to 100% guarantee that with a major earthquake like that being so intense that things still won't crumble, fall, injure people. So, if you get to there today, read through that and take the little check your understanding quiz. The next little part, which will be the consolidation, we'll do this today as well, which is just a click around and see. You can see all of the different fault lines that are major. All the reds are mountain ranges. And then we have specifically colored coded lines to show what type of fault. So you can see that the Earth land masses are pulling away and moving towards the other side of the Earth. So when we look at a map, a flat 2D map, we often look at it as North America on the left and Europe, Africa on the right. Eventually, those will swing back around millions of years from now and will meet on the other side. So we've got our blue of divergent moving away. We've got our red here of convergent. And you notice everywhere there is a red line, you have these mountain ranges forming. And then specifically, you find this right here meets all the way back around and comes on the edge of Eastern Europe and Asia down to Oceania, and it is known as the Ring of Fire, and it is the most active volcanoes in the world and where you have the highest possibility of having more volcanoes develop. and therefore known as the Ring of Fire, as it does create a almost semicircle around the Earth. So Ring of Fire might be something important that you might want to remember. So if you want to just check this out, look through it, and then I'll go over the consolidation tomorrow. Let me know if you have any questions. Have a great day.